We've now got a pretty good idea on how to create a struct and then how to edit some of the values inside of it. We're now going to start looking at some of the more advanced features around structs. The first of which is the ability to embed one struct inside of another. So let's take a look at an example of this. So at present, we've got this person type struct over here on the left-hand side. And we know that every person has a first name and a last name. Let's imagine for a second that maybe our program also needs to associate some contact information with every person. And maybe inside this contact information, the two pieces of information we want to record would be a person's email address and their zip code. Well, we can create a second struct over here, so a completely separated struct called contact info that has an email and zip code property. We can then embed this contact info struct into the person. So we have an idea of a person, we have an idea of a contact info, and then we can take the contact info and embed it into the person. So let's code up this example and see exactly what it looks like. Back inside of our main.go file, we'll first start off by declaring a second struct type right above the person one that we've already put together. So we're going to say type contact info is going to be a struct, and then we'll list out the two different fields that it has. So we'll say first off that a contact info struct has an email, which is of type string, and it also has a zip code, which is of type int. Now, if you're not familiar with zip codes, by the way, a zip code is kind of like a postal address helper that exists inside the US and some other countries. So if you're from some other country without a zip code, well, basically it's a 5-digit number that just kind of helps locate exactly where you are. So now that we've put together this separate contact info struct, we could freely create a contact info value inside of our main function. So we can freely make use of contact info by itself as much as we please. But for the purposes of our application, I think that it makes the most sense to say that every person has one copy of contact info. So inside of our person struct right here, we'll add on another field and we'll call it simply contact, and its type is going to be contact info. Okay, so this is a rather important example because it shows us that inside of a struct, we are not limited to just the very basic types that we have had access to all along, like strings, ints, floats, and booleans. But we can also take one custom type and use it to define another custom type. So let's now figure out exactly how we would declare a person that also has some contact info. I'm going to go down into our main function, and I think I'll just clean up all the code that we have in here right now. So I'm going to highlight all this stuff, and we'll just get rid of it. So now let's imagine that we want to declare a new person, and we'll call this new person Jim. Now to declare this new person, we're going to use the same kind of curly brace syntax that we saw before. So we'll start off by declaring a first name of Jim. Remember that when we are using this curly brace syntax to actually create a value of type person, we do have to use commas, whereas before up here on the actual type definition, we did not have to. So after first name Jim, we'll be sure to put in a comma right here. And then we're going to say that Jim also has a last name of, I don't know, how about Party? Who cares? Now here's where things get interesting. To create Jim, or to create this person with this contact property, we'll say that contact is now going to be a new struct of type contact info. And so we're going to place a new struct of type contact info right here. So contact info. And we're going to declare it in exactly the same way that we declared this new person. So we'll say contact info. We'll place our curly braces, and then we'll provide both the zip code and email properties. So we'll say that Jim has an email of jim@gmail.com and a zip code of 94,000. That works. Okay, so here's a great example of an embedded struct inside of another. And like I said, we can still freely create structs of type contact info if we want. We are not only limited to using them embedded inside of a person. And so this is a great way to make use or to reuse common structs across your single application. For example, sure, a person might have some contact info, but maybe a business also has contact info. And so maybe we would also have some type or some struct of type business inside of our application, and we can embed contact info inside of there as well. So now let's do our format. We'll do the printf and get the entire structure of this struct. So we'll do the same % plus v as before, and then as a second argument, we'll pass in Jim. Okay, so let's save this. And it looks like I might have a little typo in here. Very good. So one thing that I missed, and this is going to be one thing that you're going to forget a lot if you're coming from Ruby or JavaScript, whenever we are declaring multi-line structs like this. So you'll notice how we are defining our properties all on separate lines. Every single line must have a comma, even if it is the last property declaration or the last kind of property name, property value. So right after zip code 94,000, we'll put a comma, and then after the closing curly brace for our contact info struct, we'll put a comma as well. And then we'll save, and then the errors go away. Very good. Okay, so let's flip on over to our code editor. We'll run this, and now we can freely see we have first name of Jim, last name Party, and inside the struct, we have our contact property or our contact field with an email and a zip code. So it looks like this worked out pretty darn well. Okay, so that's just one more little piece of the puzzle around structs, but there's still several other features that I want to talk about. So let's take a quick break, come back in the next section, and take a look at some of the other things that we can do with structs.